Welcome to this video supplement involving finding the surface area and volume of a frustrum, which a frustrum is basically a solid right cone with its top removed. So when we look at the picture presented here, perhaps we want to hit pause and try to solve this problem before going through it together. When we start solving the problem, we want to draw in essentially the portion of the cone that's missing. So we're going to draw in this portion as demonstrated on the screen. Additionally, we will draw in the radius of the top portion of our frustrum, and we notice that we get right angles where those radii segments meet the height of the cone. In the two triangles formed, the top one and the full one, they both share this angle up top as well. So now let's draw that setup separately that we can analyze more carefully. In this setup, we know that the bottom radius is 20, we know that the top radius is 16, and in this particular problem we have that this length right here is 12. We could solve for x, this other slanted portion, by using the fact that the triangles are similar by angle. Hence, we would have that 20 divided by 16, the base of the large triangle divided by the base of the small triangle, is equal to the slant of the large triangle, x plus 12, divided by the slant of the small triangle, which is x. To solve this equation, we can cross multiply. We would get that 20x is equal to 16 times the entire quantity of x plus 12. And now we also have to distribute that 16. So we get that 20x is equal to 16x plus 192. Subtract 16x from both sides, and then divide by 4, and we get that x is equal to 48. So back up in our picture, we know that that x is 48. And now if we want to solve for the heights of the two respective triangles, for the top triangle, here's what we have. We've got that the base is 16 and that the hypotenuse is 48, and we're trying to solve for that height. Let's call it y. We would have 16 squared plus y squared is 48 squared. Now we're not solving this in exact form. We're just going with decimals. So in this case, y squared would be equal to 48 squared minus 16 squared. And we could then just take the square root on both sides, and we'll figure out the y value, which will be the height of the top triangle, 45.25. And we will keep all of the decimals stored on our calculator, but for right now that lets us see what the decimal is. For the full triangle, we know that its base is 20 and its hypotenuse is 48 plus 12, which would be 60. And let's call the other side the height z. So we will have 20 squared plus z squared is 60 squared, which means z squared is 60 squared minus 20 squared. We will take the square root on both sides, and the square root of 60 squared minus 20 squared gives us 56.57 as the overall height. If we want the volume of our frustrum, that would be equal to the volume of the full cone minus the volume of the top cone, which is going to be 1/3 the area of the base times that full height minus 1/3 the area of the base times the smaller height. As we plug things in with the full cone, the base is pi times 20 squared. That 20 comes from the 20 on the radius of the large base. And the height of our full cone we just solved for was 56.57. Then we have to subtract away 1/3 the area of the smaller base, which would be pi times 16 squared, times that height, which was 45.25. And we can just go ahead and type this all in at once to find the volume of the frustrum, which is coming out to be 11,563.34 cubic centimeters. Make sure to include the label and make sure that you have the correct label for the item that you're finding. Now in this problem, we also want to determine the surface area of our frustrum. So as we go to approach the surface area of the frustrum, we want to take this one piece at a time. So when we find the surface area of this frustrum, it's going to be the area of the bottom circle plus the area of the top circle. And then we also need the area of the sides. In order to get the area of the sides, we need the area of the sides of the full cone minus the area of the sides of the top cone. So we'll put area of the sides of the full cone minus the area of the sides of the top of the cone. And now let's plug things in. The bottom circle is the bottom circle, it's pi r squared. The top circle is pi r squared, where it's the smaller radius. The sides of the full cone would be pi times the large radius times the large slant. And the area of the top would be pi times the smaller radius times the smaller slant. As we plug things in, our larger radius was 20. Our smaller radius, as we scroll back up, was 16. Larger radius was 20. The larger slant was 60. That comes from right here. We'll plug that in. And then the smaller radius was 16. And the smaller slant, as we come back up, was 48. So that's what we'll plug in here. And now if we're careful, we can type that all in at once, which turns out to be 3,418.05 square centimeters for the surface area of our frustrum. With areas or surface areas, please break it down into individual pieces. The bottom circle, the top circle, all of the sides, and then the top sides. If you approach it as taking the area of the full cone minus the area of the top cone, it won't work out, because what you would ultimately be doing is subtracting this circle as well, and that's not going to lead to a correct surface area. So when you're calculating surface areas, please break it down part by part and find those areas individually.